All right, now on to part 2 of lesson 48. Make sure you put your heading on, your name, number, date, first and last in cursive. Remember to write the date you're working on these notes, not necessarily the date I am writing. And our subject is math. So we're looking at word problems. Every time we look at word problems, we use our annotation strategy of cubes. Circle our numbers, underline our question, box our keywords, eliminate unnecessary information, and solve. Will ran 4 miles on his first day of training. The next day, he ran 1/3 that distance. So here our numbers are written in word form, but they're still numbers, so you have to make sure. Now our question, how far did he run the second day? So we want to know how far on just that second day. So we know the first day and the next day, so that would be the second day, he ran 1/3 of that. So we are going to solve this problem using our model. So I'm going to represent each of these miles with a rectangle cut into 3 equal pieces because we're talking about 1/3. So that's my first mile, mile 1, mile 2, mile 3, and mile 4. So mile 1, 2, 3, 4. This represents our miles. We have 4 miles from that first day. Now they're cut into 3 equal pieces because we're told that we have 1/3 of each of those miles. So 1/3 of our first mile, 1/3 of our second mile, 1/3 of our third mile, and 1/3 of our fourth mile. How many total is that? 1, 2, 3, 4. 4/3. Or, because that's an improper fraction, how many groups of 3 can I get out of 4? I can get 1 group of 3, and then I'm left with 1/3. Because I could put this here and this here, and that would represent 1 full mile with 1 left over. So how far did he run the second day? Will ran 4/3 or 1 1/3 miles. Don't forget, we need to have that unit of measurement. The second day. Our next one. Debbie needed 1/3 again, of a cup of water for 1 flower. If she had 9 flowers, how many cups would she need? So we want to know how many cups. So for each flower, she needs 1/3. So I'm going to do my rectangles this way this time. So 1 flower will get 1/3 of a cup. The second flower will get 1/3 of a cup. the third flour, I'll get 1/3 of a cup. The fourth flour, I'll get 1/3 of a cup. The fifth flour gets 1/3 of a cup. The sixth flour gets 1/3 of a cup. The seventh flour gets 1/3 of a cup. The eighth flour gets 1/3 of a cup. And then the ninth one gets 1/3 of a cup. So this represents our flours. And then how many cups? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 thirds. Both of those can be divided by 3, or another way to look at it is they both have the common factor of 3. 3 times 3 equals 9. 1 times 3 equals 3. So they have this common factor of 3, or I could divide both by 3. This means I have 3 whole units, or 3 divided by 1 is 3. I have 3 whole cups I'll need. This would fill in here, here, so that would make 1 cup. This would fill in here, here, 2 cups. Then this would fill in here, here, making it 3 full cups that she would need. Debbie needs 3 cups of water for her flowers. Okay, so for the first 2 problems, we used models. Now for these second 2, we're going to use equations to help us out. A bakery used 3 cups. Also, remember on each of these, we do want to look at the units. So this was the unit of measurement was cups. Again, we're looking cups. A bakery used 3 cups of flour to make a full-size cake. If they wanted to make a cake that was 1/2 the size, how many cups of flour would they need? So we want to know how many cups of flour if we need half the size. We don't know the total. We don't know the total cups of flour. But we do know that it takes 3 normally. So I need half of 1 cup, half of a second cup, and half of a third cup. Oops, sorry. So the cups of flour, I need 3 times 1/2, or 1/2 of 3. If you forget how to multiply, remember 3 whole units. You can write it as 3 over 1. And then you can multiply straight across. 3 groups of 1 is 3. 1 group of 2 is 2. So I need 3 halves. How many groups of 2 can I get out of 3? 1 full group. and then I'm left with 1 piece. So I need 1 and 1/2 cups. I could use, if my whole cup's dirty, I could just use the 1/2 cup 3 times, but it's important to be able to see it 2 different ways. So for a cake half the size, the bakery will need 1.5 cups of flour. Remember, this is a complete sentence. Make sure you capitalize and you have your punctuation. Okay, our last problem, we're going to make an equation again. A dog groomer could clean 6 dogs in an hour. How many could they clean in 5/10 of an hour? So we're looking at this. We're looking at how many they could do in less time. Okay, so normally, so we're looking at total dogs. We don't know the total, so we add or multiply. And normally you can have 6 dogs, so we're going to represent the 6 dogs in an hour. You can clean the full dog in an hour, 6 of them. Now if you only have less of time, I can only do 5/10 of a dog in 5/10 of the time. Of course, you wouldn't actually do 5/10 of a dog. You would finish cleaning the dog before moving on to the next one. But this is a way of looking at it to help us create our equation. So if we had 6 groups of 5/10, or doing 5/10 of the 6 dogs, how many complete dogs would we be able to clean? So we can represent the 6, the whole number, as 6 whole units, not cut up into any pieces, 1 whole piece. So 6 over 1. And this can help you remember what to multiply. 6 times 5, or 6 groups of 5, is 30. 1 group of 10 is 10. $30 and 10 can both be divided by 10. They have a common factor. And then 3 whole units, or 3 divided by 1, is 3. 3 whole dogs can be washed in 5/10 of an hour, because 5/10 is half. So half the hour, half the dogs. The dog groomer can clean 3 dogs in 5/10 of an hour. Okay, so now we've looked at solving word problems having to do with multiplying a whole number to a fraction. So let's go ahead and practice some more with that. Thank you for joining me.